الله لا يستحيي أن يضرب مثلا ما بعوضة فما فوقها فأما الذين آمنوا فيعلمون أنه الحق من ربهم وأما الذين كفروا فيقولون ماذا أراد الله بهذا مثلا يضل به كثيرا ويهدي به كثيرا
focus on the behaviors that I think fruit flies excel at doing. And so I want to show you a high-speed video sequence of a fly shot at 7,000 frames per second in infrared lighting. And to the right off screen is an electronic looming predator that is going to go at the fly. The fly is going to sense this predator. It is going to extend its legs out. It's going to sashay away to live to fly another day. Now, I have carefully cropped this sequence to be exactly the duration of a human eye blink. So in the time that it would take you to blink your eye, the fly has seen this looming predator, estimated its position, initiated a motor pattern to fly it away, beating its wings at 220 times a second as it does so. I think this is a fascinating behavior that shows how fast the fly's brain can process information. Now, flight, what does it take to fly? Well, in order to fly, just as in a human aircraft, you need wings that can generate sufficient aerodynamic forces, you need an engine sufficient to generate the power required for flight, and you need a controller. And in the first human aircraft, the controller was basically the brain of Orville and Wilbur sitting in the cockpit. Now, how does this compare to a fly? Well, I spent a lot of my early career trying to figure out how insect wings generate enough force to keep the flies in the air. And you might have heard how engineers proved that bumblebees couldn't fly. Well, the problem was in thinking that the insect wings function the way that aircraft wings work, but they don't. And we tackled this problem by building giant, dynamically scaled model robot insects that would flap in giant pools of mineral oil where we could study the aerodynamic forces. And it turns out that the insects flap their wings in a very clever way, at a very high angle of attack, that creates a structure at the leading edge of the wing, a little tornado-like structure called a leading edge vortex. And it's that vortex that actually enables the wings to make enough force for the animal to stay in the air. But the thing that's actually what's fascinating is not so much that the wing has some interesting morphology. What's clever is the way the fly rather flaps it, which of course ultimately is controlled by the nervous system, and this is what enables flies to perform these remarkable aerial maneuvers. Now, what about the engine? The engine of the fly is absolutely fascinating. They have two types of flight muscle, so-called power muscle, which is stretch activated, which means that it activates itself and does not need to be controlled on a contraction by contraction basis by the nervous system. It's specialized to generate the enormous power required for flight, and it fills the middle portion of the fly. So when a fly hits your windshield, it's basically the power muscle that you're looking at. But attached to the base of the wing is a set of little tiny control muscles that are not very powerful at all, but they're very fast, and they're able to reconfigure the hinge of the wing on a stroke-by-stroke basis. And this is what enables the fly to change its wing and generate the changes in aerodynamic forces, which change its flight trajectory. And of course, the role of the nervous system is to control all this. So let's look at the controller. Now, flies excel in the sorts of sensors that they carry to this problem. They have antennae that sense odors and detect detect wind detection. They have a sophisticated eye, which is the fastest visual system on the planet. They have another set of eyes on the top of their head. We have no idea what they do. They have sensors on their wing. Their wing is covered with sensors, including sensors that sense deformation of the wing. They can even taste with their wings. One of the most sophisticated sensors a fly has is a structure called the halteres. The halteres are actually gyroscopes. These devices beat back and forth about 200 hertz during flight, and the animal can use them to sense its body rotation and initiate very, very fast corrective maneuvers. But all of this sensory information has to be processed by a brain. And yes, indeed, flies have a brain of about 100,000 neurons. Now,